possible cause of clash, physical consideration. This is a channel for student who is learning physics in college. We try to utilize the physics knowledge to understand the current event. This is significant event, so I picked this one. So as usual, the information is trickling out from the Boeings and other sources. So based on those limited information, we're going to speculate what was the problem. Okay, this time the new information came out. What is a faulty system? Boeing knew about it. So what's happened is there's two accidents, one in Indonesia, Lions Air, and Ethiopia, second one. After Indonesia, Lions Air accident, Boeing turned off the software for the new delivery of airplane to Southwest and others. So that time they knew something wrong. And what's wrong is there's the pitch detector here. There's a nose position. Is an airplane flat or nose up, pitch up, or pitch down? Okay, and in the previous video I explained this kind of simple detector is faulty. It never pick up the nose position correctly. So they turn off that software that gives a warning that the pitch is too much. They call this angle the angle of attack. Okay, and the safety feature shows if airplane is nose up too much, it shows a warning, but that warning is not working, and Southwest pilot reported, and Boeing said that's okay, just use it. Okay, so first let me explain to you why the nose up is a problem. Okay, what happened is the airplane get lift force because this wing has a hump on this side and relatively flat, and airflow through this V1 and this side V2. V1 is faster than V2, and balloon is low. You already learned the physics. This side, if the source of the air is the same here, then since this guy goes faster, the pressure drop. So here's a P1 and the P2. Obviously P1 will be less than P2, so it's push up the airplane, and this pressure is a lift. Okay, but if it's too angle of attack is too much, is the flow of air changes suddenly like this. Okay, and you lose a lift, it start falling right away, and this called stalling, airplane stall. So in order to avoid this, there is a safety mechanism by software that detect the pitch angle of attack and give a warning. If you bring this nose up beyond this, it's dangerous because you suddenly drop, you lose a lift. Okay, and that software was turned off for the new delivery of Southwest here. And why software is bad, or this detector is bad, and this detector, as I explained in previous video, very simple. There is a flap, the top view is like this, and the air flow, and this flap follow the direction of air, and if it's level, the flap is here. But airplane nose goes up, then flap indicate here, and the software said, oh, we're nosing up. Okay, and how many degree typically? I did a calculation. If 5 degree is tangent, this is a tangent, and if airplane is flying 600 miles per hour, it's 266 meter per second. That means climb rate per second is going to be 23 meter per second. This is very significant. With this kind of rate, to reach from ground to 10,000 meters takes only 7 minutes. Okay, and usually when you have experience, when you get on airplane, it takes like 20 minutes to get up to correct say 20,000, 10 to 20,000 meters height, because the speed is increasing. It's not 600 miles per hour yet, but 5% is enough for commercial airline. It's not the jet fighters. Okay, 5% is significant, and this 5% need only 23 meter per second down flow of air. If air is flowing this way, then the flap indicate here already. So what's happened is, even airplane is level flying and try to move up, so pilot use a trim this way to nose up. The software prevent that, because software thinks it's already 5% nose up and wouldn't let it make going higher anymore. So pilot had very hard time to make a nose up. And beside, the engine position was changed from below winged to forward and up. And in the first video I explained this gonna eliminate the force, the moment to make a nose up. So pilot had a hard time to climb because of software limiting, and software could be limiting. This is a speculation here, because of this faulty detector. This kind of detector is fooled easily by the downwind or upwind. Okay, and once it start going down, okay, the airplane is moving this way, then this kind of detector show its level. It doesn't show that it's going the nose is down. So this is a big problem. This kind of simple detector doesn't work. The software just think, hey, you can't move this up because it's level. So basically it's a faulty detector with software together, and that's current speculation, because information come out very slowly. It's just tickling out from the Boeing. I mean, they may know a lot more about this one, but they knew something after the first Indonesia's accident, and so they turned off the software, and they didn't let the Ethiopian Air knows about that. So what's happened is the Ethiopian airplane depend on the wind direction. This kind of detector, pitch detector, is easily malfunction, and based on the malfunctions detector, the software is going to fight with pilot. Okay, so that's the current speculation we have based on the limited information. Okay, so we still follow this and see what is the final determination of the cause of the accident. Okay, thank you for listening, and if you like, subscribe.